Talking Industry, topical debate from the worlds of automation, manufacturing and engineering. Brought to you by DFA Manufacturing Media.
Hello. A very warm hello. Can you hear? A very warm welcome from Talking Industry Live and me. I'm Aaron Blutstein. I'm the editor of Smart Futures and Planterworks Engineering magazine. And our topic this afternoon is bridging the engineering skills gap for factories of the future. Hopefully it's going to be a fascinating discussion as addressing the UK's increasing digital skills gap is of pivotal importance to help future-proof both our recovery and engineering future. Government and industry both need to address not just the immediate term skills and training needs, but also the mid-term. At the heart of a future education and training system is the need to help manufacturers adopt to new digital technologies by supporting schools, colleges, universities and new apprenticeships across industry. Unfortunately, it's been an ongoing problem that demand for digital and tech talent and skills is greatly outstripping supply. This has only increased amid the pandemic recovery. So it's important that businesses look to options such as apprenticeships to build a talented homegrown workforce and upskill employees at all levels. So our panel will examine what's needed to support these needs and help bridge any digital skills gaps. To help us do this, the discussion will be moving through the age groups from early years to youth and then on to apprenticeships. Just a quick reminder that all our panellists will chip in where appropriate because it's intended to be more of a panel discussion rather than just a lecture. So we actively encourage the audience to participate and chip in where you feel necessary. So without further ado, let me introduce you to our three excellent panellists this afternoon. I'll quickly list our speakers and then go around in reverse order so they can introduce themselves a little bit, and then we'll get straight into our discussion with the final speaker then beginning the discussion. So in reverse order, I'll pass over to Charlotte Swain, who's the Deputy Director for Delivery at the MTC's Advanced Manufacturing Training Centre, to introduce herself.
Good afternoon, I'm Charlotte. As mentioned, I work at MTC, but I work within the training team, so we're in AMTC. Our main focus is apprenticeship provision and level 3 engineering technician standard, but we also deliver quite a lot of upskilling programs which are designed for employers or a bespoke package and training in the workplace. And the aim really is to make sure we're preparing engineers for the future, not just now or 5 years' time, but for 10 years' time.
Susan?
Good afternoon, I'm Susan Scurlock. I'm Chief Executive of Primary Engineer, and the work that we do is focusing on the development of teachers so that the long-term impact of engineering can be felt in the classroom. So all our projects are for every child in the class, and we work right the way across the UK developing that ethos of engineering in a classroom environment.
Good afternoon, my name is Russ Barnes, I'm an RAF officer. I run the RAF's Youth in STEM programme, which we aim to reach just over 1 million students a year. And our aim is really to encourage as many young people as possible to take STEM subjects when they come to GCSE selection.
Thank you, Russ. Could I move back to Susan? And Susan, could you start by giving kind of your overview of where we are with trying to promote engineering skills to the primary school age?
So I think one of the biggest challenges that we've got in education is where engineering sits as a topic. So engineering isn't taught in primary schools, it may be touched on in some secondary schools, so you've got to find the niche for where engineering will fit. And quite often that sits within design technology, and if you look at design technology as a topic, primary teachers very frequently have not had the training to be able to deliver design technology in the classroom. So consequently, they're not confident in giving 30 kids hacksaws and getting them to make things. So how do you encourage them to be able to see that the practical application of maths and science in a design technology context is engineering. So what we do is we train teachers, we link engineers to projects within the classroom, so the engineer has a role to play, and that role is about contextualising the learning so that children and teachers understand more about what engineering is and what the sector is. But when you look at the influences on young people, teachers' lack of confidence within the engineering sector, being able to tell children that there's a career in the sector, is very high. They're not aware of it, they're not confident. So the way we've addressed that is to create short courses where teachers have to interview engineers to understand more about what's going on locally, what's going on in the bigger picture, the bigger world, and then being able to relay that back into the classroom with children on a regular basis, so that what you're getting is almost a drip feed, but constantly engineering sitting in the background of what's being taught. And when you think about where companies exist, quite often they're behind a white wall and a gate. And you drive past it and you become quite blasé about what goes on there. It's just a white wall and a gate. But actually, behind there will be all sorts of innovation, all sorts of careers, all sorts of opportunities for young people. But because they're not talking to local schools, because they're not having that conversation with teachers, then quite often that's missed. And that opportunity to attract local people in, get them skilled up, and get them to be aware of not only the engineering jobs that are in there, but the jobs that the wider manufacturing industry have, that's where we start to see real differences happening, where they start to see, being able to have those conversations more widely. So I think for us, it's about raising the stakes, not only in terms of the skills, but in terms of the awareness of the sector and the opportunities that people would have.
Okay, thanks. I mean, why within schools, from your experience, are the teachers experienced enough to be able to talk about kind of engineering as a subject?
I would suggest they're not. There's been a recent study in Scotland by Education Scotland where they've got 70,000 practitioners, and they've identified that the vast majority of those 70,000 do not have enough confidence to be able to say what an engineer does or a career path to becoming an engineer. So we're working with Education Scotland to actually raise that understanding across all those practitioners so that they can take that back into the classroom. So I don't think teachers are confident enough, but then I would actually level that at most people. If you stop most people in the street and said, how do you become an engineer? I would imagine a lot of people don't know that either. So it's about raising the awareness of the sector right the way across the board, really.
Do you find that the children are very engaged with wanting to learn about engineering? I mean, especially when you look at, most children will have access to computer games, to their apps on their phone, on their parents' phones. I know from my own experience, and that kind of leverage digital skills are actually growing within children at an early age. So. Are you finding that those skills are coming across in school, that they want to develop engineering skills along with new digital technologies?
I think we see a lot of children that are engaged in making things. So you look at children at the academic side, and quite often children that are academic struggle with making practical things. So their challenge is to turn that into a practical outcome. And then you've got the children that are very practical, and you want them to be able to apply the maths and science, the technical side of it. So in terms of having an engineering project in a classroom, you're stretching all ends of the spectrum of children. What you do find, though, is that children get engaged in those building processes. And whilst you're talking about engineering, you're actually developing a lot of other skills that are required around resilience, around practical problem solving and creativity, and embedding that creative idea within an engineering context and then nurturing that. That's the bit that's really important. But I think that from what we see, children are very engaged in it when they get the opportunity.
And can children, in your experience, learn at different levels? You have those children who who are better at STEM skills than others, and can you engage those children who aren't necessarily natural engineers and try to get them engaged with the subject, because it gives them other opportunities later on as well, not necessarily within engineering, but with other skills. And is there a spectrum of talent, effectively?
Well, you will have that in a classroom. I think what engineering brings into a classroom is that it engages everyone. So there's no cut-off. You're not doing it as a club, you're not doing it to the already converted. You're giving the opportunity to every child in the class to engage and find their space in it. So that's the important bit, is not saying you can be an engineer and you can't be an engineer. It's let's everybody have a go at it and see where we go from there, and then drawing out those talent bits as we go along, so that you're encouraging it in a year-by-year process.
What sort of activities do you engage with then to actually encourage children to actually take up or to be more of an interest in engineering?
Well, we do quite a lot. We train teachers, we have projects around vehicles, around construction, around rail. One of our big projects at the moment is a rail project. But we also ask children, if they were an engineer, what would they do? And encourage them to find problems and create solutions to them. And that's one of the biggest programs, where you're not giving children the question. You're saying literally, go and find a problem and design a solution to it. And when you think about schools, more often than not, you're in a classroom and the problem is presented on the board, and there's a right answer and a wrong answer. This is a project that allows creativity to really flower within an engineering context and then celebrate it nationally. So we do a range of projects, and I think that, for me, is the important bit. There's always a what next, there's always something else that you can do, ready to catch that interest.
And I mean, I know that you obviously you start from a very early age, don't you?
Yeah, we do.
Engineers.
Yeah, we've got early years
early
engineering.
years and then primary.
Yeah, and then primary. Yeah.
So how do you keep that interest going from from a very, very young age up to going up the age groups? Because I know you have different schemes, so it would be interesting to hear how you.
I don't think you make it something that's so a hard sell. It's something to a teacher that is being successful and encouraging their children to be successful within the curriculum and the experiences and the resilience. And because you're providing that for the teacher, it carries on all the way through the school. So it kind of gathers its own pace. And that way then the children get the experiences of it all the way through.
So from primary engineers, the next stage is secondary engineers?
Yeah, we do have secondary, yeah.
So that's obviously where Russ, you would be more, you would start to kind of engage with the slightly older children. Could you explain a little bit more about how your involvement with the RAF, and how, from a youth and STEM point of view, that sort of carries on from Susan?
Okay, I'll just talk for a couple of minutes about why we do what we do and the importance of running a youth programme. And I'll use the example of how the RAF has run our programme to explain that. But the lessons we've learned are as applicable to any other organisation, to be honest. I mean, first thing I've got to say is, when you're dealing in a youth space, so you're dealing with children at an age before they make their GCSE selections effectively. So what you're doing is really taking a bit of a leap of faith. You're not recruiting, you're very definitely not recruiting. You're doing is helping young people to understand the opportunities available to them if they maintain certain subject choices. So you're effectively trying to bring them into the pool of those people who have certain qualifications that open up their horizons. So for us, the journey began right back in 2008, when a very inspirational woman who was one of my predecessors in this role spotted the fact that there would be a skill gap in STEM qualified people in the mid-2020s. That was long before it was talked about publicly, or government became really aware of it or talked about it in any meaningful way. And she persuaded the people who run our budgets to spend some money on investing in youth engagement, because if you want to really invest in youth, i.e. upskilling young people to have an effect in the future, you're talking about 10 years of investment minimum. You're talking about going to kids who are very young and persuading them that they might think of something to do in their mid-20s and that they would have to be skilled for now. So she managed to persuade people to take this leap of faith. And our program began dealing with 11 and 12-year-olds, just as Aaron suggested there. So you're trying to engage young people before they make their GCSE selections. Persuade them that engineering is something they would be interested in, that the skills they need to do that, the STEM skills they need, taking subjects like physics at GCSE. I mean, nothing could have persuaded me with wild horses to take physics at GCSE at that age. but I only wish I'd met somebody who could have inspired me to do exactly that, and that's what we try and do. So our program began very much with 11, 12-year-olds, but as the years passed, we found the increasing amount of evidence suggests you've got to engage kids younger than that. You've got to get to them before the stereotypes about modern life are formed. I'll give you an example of how we came to this. Back in 2017, there was a charity called Primary Futures, ran a little competition nationally, and they basically asked primary school kids to draw people in work, pictures of people doing various jobs. And they got nearly 8,000 responses. And across those 8,000 responses, almost every teacher was a woman, drawn as a woman. Every single nurse was drawn as a woman. Every single engineer was drawn as a man. Every pilot was drawn as a man. And that's not because that's the only roles open, that they are gender limited. It's simply because that's the experiences that young people are seeing on the TV, in life itself, in conversation around them. They assume that that's the case. So in order to influence young people that they could be something else, you've got to get to them before those stereotypes are ingrained and persuade people in primary school, young children, that they could aspire to do something that they don't see among people older than them. There's a phrase I often hear that is, you can't be what you can't see. Now, I'm not a big fan of that because nobody would ever have changed anything if you can't be something different. But it's much easier to become something if you see an example of it. So why would a young girl decide she wants to be an engineer in software design if she's never seen anybody else undertake that role, if she doesn't think it's accessible? So it's very important to persuade people with role models, with examples, that you can step into those spaces, and that's a lot of what we do. Now, in order to run a youth program, I have to say one of the important things you've got to do is you've got to work with partners. People who are like-minded, who share your view, who equally recognise they've got to take a leap of faith in engaging young people and support them without any tangible benefit being given to them, and certainly not provable over many years. Working with those partners from academia, from industry, charities, education sector, all very important. And you've got to think about how you engage as well. I mean, we choose to engage in three particular ways. The most beneficial kind of engagement you can offer in any kind of school or context is face-to-face engagement. You take professionals who understand their role, who can stand in front of students and talk to them in a real-life way, run activities that have an engineering focus that are fun to do. How do you make coding interesting? Well, you take robots into a classroom and you teach kids to code robots that can do things with them. It's a lot more fun than teaching coding on an algorithm on a blackboard, for example. So face-to-face engagement will always achieve, a better result. You do that in residential courses, in school visits, large-scale events, things like this, where you bring children into stands and talk to them about engineering, show them how to do things. But in this day and age, we've also developed a quite wide virtual engagement pattern, and the last 2 years have taught us very much how to do that. So you engage virtually, but the best virtual engagements invariably come with a face-to-face element. You send kit to the schools you're engaging with. They work through a practical demonstration which you support online. So it gives them the best of both worlds. But you also need to think about resourcing. One thing that schools lack a lot of is properly curriculum mapped resources that make things they've got to teach fun. Now, one thing that Susan talked about earlier, primary school teachers are invariably not STEM specialists. They don't have the skill set. And the STEM curriculum in primary school has increased quite substantially in recent years, but the output of it hasn't. And that's because the teachers simply don't have the skills or the knowledge or sometimes the confidence to teach what they need to teach. So if you can help them by giving them resources and support that is properly curriculum mapped, understanding how they support young kids and how they are ticking the curriculum boxes as well, that also has a real benefit. So in summary, I'd say what we try and do is we increase the STEM capital, if you like, of young people. We give them more experience, more understanding, help them to aspire to do something they might not otherwise have done. We do that largely by creating equal access. You've got to get to people you would not normally get to. It's not good enough to work within 20 miles of where you happen to live or where your factory, your organisation happens to be. You've got to get into those most remote rural places. Some of the poorer communities of the country don't have good internet access. They live a long way from anybody else, and you've got to provide that opportunity to people who would not otherwise get that opportunity. That's very important. And you've also got to add value. So if you support teachers, if you give something they need to do, you give it a real-life context, you give it a fun aspect, they will welcome your support. And I have to say, if it's free, it's that much better for the school as well. Aaron, is that enough?
Yeah. So how do you mentioned about equal access. How do you get to those children and to those groups?
Well, actually, one place that's easy is in cities. You go to most cities, to get access to the poor areas, to give advantage to kids who would not normally get that, that's actually quite easy to do, because you can track things like the Free School Meal Index tell you how many kids in a given school are likely to come from disadvantaged backgrounds. And by approaching the school and offering resources that are often free, support that helps them, I say in the curriculum that is free, they will take that offer gladly. Where it's harder is getting to remote rural communities. Last November, my team were up on the Isle of Skye, going to all 22 schools up there, some of which only have a dozen kids in. And they've never had that kind of outside support. Nobody takes the trouble to drive 500 miles to the Isle of Skye to spend a week helping young kids. If you can do that, if you can project that, that is so very helpful. I have to say, during COVID, the kids that suffered most are the ones that come from poorer backgrounds, where the only IT device in the house is the mum's phone, or they come from more remote areas where the IT connectivity is so poor they could not manage keeping up with lessons online. And they are the kids who have suffered the most during the COVID pandemic. So they're the ones that may need most help.
And are you having success of accessing those children?
Yeah, I would say we absolutely are. We reached a little over 1.5 million kids last year with our programme. We're very proud of that, because it's, it is hard to do that with limited resources. And you can appreciate you are taking a leap of faith, engaging people far younger than any age you would ever see benefit from. So it's hard to fight for a large element of budget to do that. But yes, absolutely, I think we're having an effect. In fact, I would say back in 2008 when our programme began, the number of women employed in technical jobs in the UK was 8%. That's really quite poor. It's now 14.5%, and whilst that is not a huge difference, it is very measurable, and that's largely due down to the huge amount of effort and large number of companies and industries have made to persuade girls that engineering is something they can get into. Imagine where we'd be if they hadn't done that in the last 10 years. And worth stressing that if 20% of girls who are in employment were employed in STEM jobs, we wouldn't have a skills gap in STEM. The problem would be solved. So the solution really is getting to those who would not normally consider a career in that area.
And do you actually keep track? I mean, this is actually for both Susan and you. Do you actually keep track of your successes and how the children, if they enjoy engineering and STEM subjects, how do you actually how do you monitor their success effectively? Your success. You
can monitor the success of an activity you do in a school, because part of the condition of doing it is the teachers give you a degree of feedback, and you can always monitor at the time, because feedback at the time is great. Most kids love what they've just done that was fun. Whether they remember it 6 months later is another matter. That's what I mean about you have to have more than one engagement. You increase their STEM capital, but really monitoring the benefit to you as an organisation from engaging with young children, that is exactly like I said, it's a leap of faith. You can't really achieve that. I mean, in the RAF, when people join our service, we ask them, why they've chosen to make that choice, why they've chosen to come to the RAF. And we have, in the last 3 or 4 years, had an increasing number of people who talked about having been engaged in youth activity that involved RAF people. So, yes, we see it, but it cannot be a motivation to do it. You have to assume that by benefiting enough young people, that you as an organisation who requires those skills will benefit as well. It is absolutely a leap of faith.
I mean, Susan?
Yeah, I was just going to add that it depends how you measure. So if you look at the number of children that apply for an apprenticeship, and you look at the number of university courses that offer engineering, there's not very many of them that don't get filled. So you've got to actually start to think about how are you measuring success if right at this moment you've got 4,000 young people applying for an apprenticeship to one company. What happens to the other, the 50 that are successful, what happens to everybody else? So there is that groundswell towards, but I think the industry itself is looking for skills at different ages, and sometimes when it talks about the skills need, it just lumps it together in one number, and it doesn't really think about the spread of ages that it needs. It doesn't need them all at 18 and 22. It needs them at different ages, and that's a different project in itself as how to get those people into those roles. But if you're measuring the number of kids that are going towards engineering now, you have to look at the number of children that are applying for apprenticeships, the number of people that are applying for university places, and measuring how many of them aren't successful and what happens to them. So it's a question of what you're measuring, really, I think.
Charlotte, have you found that, or do you monitor or find out where your apprentices have kind of their progression?
Yeah, part of what we're judged against is monitoring the impact of our training. So we keep a check of what roles they're in when they leave us, and then where they are 6 months' time, 12 months' time, and we have to keep in touch with them, and also in the hope that they'll come back to us for further learning, whether that's a higher level apprenticeship or commercial training, because what shouldn't happen when they finish with us and they've done their endpoint assessment, we shouldn't just be waving them off and saying, well done, you've finished. That's just the start of a whole long career, we hope, in engineering. So to keep future or even to keep current, it requires them upskilling and continuously accessing more training as they go through.
Thanks. Ross, I'm just curious, because we spoke earlier before the session. You were telling me how you have some difficulty sometimes going into schools because of how you can actually teach engineering as a subject when you go into from an RAF perspective.
Yeah, I said everything we do, we curriculum map, but there's a huge amount of links in the curriculum that you can link to your own organisation, whatever that might be. I mean, we are heavily involved in aerospace, as you might expect, being an Air Force organisation, but also in space technology, in cyber activity, and these are areas which are covered quite extensively in the curriculum. So if you will offer engagement that is curriculum mapped to, say, coding, as I said before, using robotics is a very good way of making young people sit up and take notice. For some reason, when you produce anything that's Lego orientated, you produce a Lego robot in a class, kids from 6 to 16 seem to think it's wonderful. So you find something that is fun, that is interesting, that also hits the needs that the teacher has in engaging, and you make it relevant to your own organisation. It's quite easy to develop engineering and talk about aircraft. The development of the jet engine is something symptomatic to the RAF, and yet it's a huge part of modern life. Most of us would not have travelled all the places we've been without jet engines. So you can give that a real-world context. And I think that's probably easy for most industries to do. If you look through a national curriculum, anyone that has a scientific background to what they do can certainly pick through the curriculum and see things relevant to them. And I've seen some very good STEM activities delivered in schools based on wind power, for example. Very topical at the moment. Schools are teaching environmental and green energy in a very meaningful way, and teaching that in a way that engages students is sometimes a far more beneficial way to get the point across.
Mm-hmm. Are you finding that the skills that you're actually talking about are skills that can be applied for jobs that haven't actually been thought about?
Yeah, it kind of has to be. I mean, a couple of years ago, the RAF announced the formation of the RAF Space Command, and we all thought that was a strange thing to hear so recently. But actually, the first person was recruited into the RAF Space Branch 17 years ago. You have to recruit skills a long time before it may even be widely understood or widely known. I certainly went through school where there were no computers. The most advanced computer on the school when I was 18 was a Commodore 64 game system that had a 1 megabyte hard drive. I find that inconceivable now that we would manage life without smartphones and without computers. So you have to think about the skills that will come along in 20 years. Absolutely.
Mm-hmm. Okay. Charlotte, can I just bring you in here just to explain a bit more about, from an apprenticeship point of view, and how that leads on from Russ's age group?
Yeah, so some of the key words that both Susan and Russ have said are critical to our apprenticeship programme. So that's that investment, the partnership working, the inspiration, all of that we add to our programme to make sure it's successful. At MTC Training, we operate mainly a level 3 apprenticeship standard in engineering technician, and that is approved, accredited by the Institute for Apprenticeships and Technical Education, and it's a 4-year programme. So when you're working with young people, and not all of our apprentices are 16 to 18, quite a huge number of them are in their 20s and into 30s, actually to talk about a programme that's 4 years in duration is a big investment when you're young. It's a long way into the future. We work very immediately. Everything is to hand. We've talked about smartphones, and everything happens immediately. So to say to a young person, we need you to invest in 4 years of your life, to be an apprentice, that's a big commitment. But what we do with our training programme is we have all of our apprentices for that first year full-time in centre, and our main aim in terms of focusing on the future is the first year is about teaching basic quality, high standard engineering skills. Then to the apprenticeship standard, we wrap around more of our future skills technologies, which it links in closely to what the main aims of MTC are. So alongside the qualifications they'll do as part of their apprenticeship, of which there are 3 within the engineering technician standard, we also add a huge enrichment programme to that, which is all about future skills and making them employable, not just in the short term, medium term, but 10 years into the future. So it isn't part of their accredited programme. And this is where the investment from employers is key, because hopefully they'll reap the rewards of that and the benefits when the young person or the apprentice go back into the workplace after that first year. But we do a number of technical lectures which are based around future technologies. So we have opportunities for engineers who are working in projects in MTC to come over to speak to the apprentices, so they get exposure to see some of the future technology projects that have been worked on in MTC, the impact of those, they get to understand them. But that's also where it carries on, where you've got that spark. So the spark you see in primary school for those inquiring minds, want to do more, want to learn more and want to remember more for the future, we keep going with that, because those are the engineers that are going to have a big impact in the future. In addition to that, we also offer some online learning materials. So those are in elements that are not in a current apprenticeship standard, and they might not be in an apprenticeship standard in the next 5 years, but it is all about you've said about space technology and understanding. You wouldn't have thought about that in 5-10 years ago, but that's what we need to be ready for and what we should be preparing the young people for. So when they get to the end of that first year programme, they go back into industry, and then we just have our apprentices on block placement in year 2 and year 3. So what we do then is ask them to contextualise what they've learnt with us in the workplace, and then we add to that in the subsequent years of their apprenticeship programme. The main aim being when they come to the end of that programme, as I've said, that they don't leave us, that they still engage with us to make sure they are keeping those skills current, but also learning things that might benefit in the future. Our challenge, I think, coupled with, I think it goes along with what Susan's saying in terms of the experience of primary teachers being confident to deliver engineering. For us, it's actually having engineers to train the apprentices who also themselves have those future skills, because that's not what they're qualified in. It's not what they did at school, the university themselves. So we are very invested in upskilling our own teams to make sure they are confident to deliver those. And moving into the future, one of the standards we'll be delivering from next September is in space. So it is about making sure us as an organisation can be ready for that for the future, not just with our young people, but our own workforce. And digital skills are key to that. So our focus is no longer just English and maths, it's English, maths and digital skills in what we do, because that's what's going to bring the long-term benefit.
Mm-hmm. And do you think that schools are actually doing enough to promote apprenticeships?
Oh, it's a tricky answer to give now.
And what can they actually do to actually encourage the
So
take-up?
all schools, as part of what we're judged against, is independent in information, advice and guidance. So private training providers and colleges should all have access to young people in their schools to be able to show them what options are available. It is a challenge to get into schools sometimes to be able to do all of that, because quite often what the education routes are still quite traditional. You do your GCSEs, you do your A-levels, and what we want are young people to have the option to see all of the things that are out there for them. But we are well connected in, we do get chance, we are STEM ambassadors and we do represent at any opportunity we can at events, but we will always take any opportunity we can. Mentioned about going in with Lego into schools. When we do partnership work, Scurlock cars are also popular, they like to build those, and Meccano, anything like that which just gets people engaged. So quite often it can be seen as a potential threat, because you might be taking a young person away who could have stayed to sixth form to do their A-levels. But actually, if we were viewed as enhancing the learning experience for the young people heading towards their GCSEs, that we can come in and co-deliver and support the teachers in the schools, then I think it would be a benefit to all.
Mm-hmm. And what would you say to a student who was considering going on to university or an apprenticeship, what the advantages are And I mean, some may think, well, actually, you know, if I'm preparing for factories of the future, is the apprenticeship going to offer me the same skills that I can obtain by going to a university that may be focusing on those digital skills?
Most definitely, the end point can be the same point. So there's degree apprenticeships out there now, so you can get up to that level 6. If you are someone that likes to do hands-on and you're mixing that working, learning, earning at the same time, having an apprenticeship opportunity just gives you a different route to get in there. So you would be in a full-time job, but you've got to make sure you're doing studying. So in some ways you'll have a lot more contact hours if you're an apprentice, because you're in the workplace, and then you've got to do your 20% off the job as a minimum and do your training. But also it's an opportunity that for an employer to get that young person that they can then retain for a long time and have a benefit to the company. So if sometimes you get to the point you think, I've done enough formal education in a full-time setting, actually it gives you that opportunity to apply that learning. And apprenticeships are now not just about the qualification that you do. The apprenticeship standards now are also about skills, knowledge and behaviours. So what you're also getting from that is your personal development, that you've got behaviours that will make you employable. So it isn't just your engineering qualification. Actually, we're measuring you as an individual, as a professional, the resilience that you've got. So by being an apprentice right up to potentially the degree level, you're learning more than just your qualification. So that should then take you through your whole education and employment journey.
And Susan, from your experience with secondary schools, are they talking about apprenticeships, or are they really focusing on STEM skills to kind of move up to universities?
Well, I think it's a long time since I was a secondary school teacher, to be fair. Yeah. But I think that the work that we do in Burnley, for instance, is quite interesting, because we work with all the primary schools and we have access to all the secondary schools as well. And we are actually seeing at the local college more children and young people applying for STEM-related subjects. I think secondary schools do have a responsibility to talk about apprenticeships, but I think it would then revert back to the amount of knowledge teachers have about those subjects to feel confident about them. So it's one thing to have a group of people come in and talk about apprenticeships. Mm-hmm. The children and the young people will then turn to the teacher and say, what do you think? Actually, if that person doesn't have that experience of being able to talk more about it, they're potentially going to talk university instead, because it's a safer option. So I think there's still a lot of dialogue that needs to be undertaken in schools around apprenticeships and with parents. And I think for me personally, the bit that seems to stand out for apprenticeships against university is that we all understand that if you get a degree, you can end up anywhere. I'm not sure I know that about an apprenticeship. So I think that maybe it's that knowledge about what the pathways into careers are and what the options are at the end of them that still needs to be shared with schools for teachers and children and young people to be confident about the ability to sidestep and do something different with that same course qualification.
Do you think that parents are potentially the problem?
I would never say a parent is a problem. I think that parents always have their own opinions, and their opinions are based in their own experiences. But parents want the best for their kids. So making sure they have the access to that information, mm-hmm. I think it's still an information thing.
Mm-hmm. Russ?
I have to say, one of the problems here is actually the way our education system is funded, to be honest. Schools get their funding based on the success of their pupils. If more kids pass exams to a high level, they get more money. If the best kids stay on in school, they get more money. Well, if you work in the funding in that environment, why would you encourage the better students to go somewhere else and learn later on in life? Why would you take the risk that students who are not doing so well in their exams, might just scrape through, but they're a bit of a risk? Why would you put them into those exams and risk your whole exam pass rate dropping? Now, that's not a fault of teachers, it's not a fault of schools, it's a fault of a system that funds them in that way. And I think if more students who were borderline in science subjects were allowed to take those subjects at a higher level, they just might surprise their teachers and the schools and get a pass through. I've met many engineers who scraped their exam results at GCSE and A-level. literally going through pure science and physics, just pass. But they became successful engineers in the end. And that's because a teacher had faith in them and let them do a subject for which they were borderline pass. And that's about the funding. And so on the point on apprenticeships, I spoke to two engineers from a company called Leonardo a little while ago who were both doing very much the same job. One had been an apprentice, one went to university, studied engineering. They were both doing virtually the same thing. When I asked them what the difference was in their lives, the one who had been to university said he'll be paying his debts till he's 50 for his education. And that was the only tangible difference in what they had achieved. You know, people don't know enough about apprenticeships. There is a route that takes you to engineering which doesn't necessarily require the level of investment from the individual and their family, which traditional routes push them down.
So this is a question to the whole panel. So would you say that apprenticeships are probably the best way to actually bridge the UK's current engineering skills gap?
I don't know if it's the best way. They are an essential component, and they're not understood well enough. My kids all went to a grammar school. They were fortunate; it was just a good school local to where we lived. But the push there from the day they joined that school is they should all go to university. They're persuaded from 11 they should aim their path at university, and it's not a suitable role for every single person. Now, if we send every child to university, they can't all earn university level earnings that we tell people they'll get out of a degree. We need skill sets, and skill sets are attractive in lots of ways. People have to understand that apprenticeships are a very viable and equally important component of education.
The key bit is the employer investment within the apprenticeships and the employers that you're working with. So the programs are designed to deliver the skills and the knowledge and behaviours, but if you can work in partnership and employers drive apprenticeships, which is what they should be doing with apprenticeship standards, we are then able to put together programs that benefit them. And I think that's where apprenticeships can, when used flexibly and you work closely together, that's the benefit that you can get now and for the future, because if employers are able to share with you the skills they think they're going to need and the skills gaps that they've got currently and see coming, we can address those much quicker with the programs we put together. But often it does take investment from the employer more than just the 20% off the job that we have them. So that's in time and support from them. It might be with kit and equipment, but that's the way to make a difference.
And I just add, I'm not sure there's enough places to take all these apprentices that want to be apprentices. You know, I think BAE Systems get 4,000 applicants for 50 apprentice places. So what happens? They've got to go somewhere, and if there isn't the somewhere, what happens next? So I think there's a balancing act between the two.
So how do we fund the extra places?
Well, actually, there's also quite a dramatic shortage of STEM qualified teachers. So you try and get a physics teacher in a school these days, that's quite difficult. If there aren't the teachers, how do you ever create the pupils? We regularly talk about there's not enough doctors in this country. Well, every course that trains doctors is full. So why aren't there enough doctors? Well, that's because there's not enough places to train them. There's not enough hospitals to take in the students, and not enough instructors to teach them how to be doctors. The only way you affect that is you put more investment into the education. And that can only happen if people who are qualified in those skill sets move into teaching or contribute to teaching in some way. Hard to do, I know. Companies can help that by releasing people to support this. And an apprenticeship scheme is an ideal way of doing that.
And how do you actually promote them? Because I was talking to you, Charlotte, earlier about how I came across a company that was trying to promote their scheme, and they said they had one applicant, and they advertised it in the job centre. So what should companies actually be doing to attract pupils as well? I mean, Susan, obviously you mentioned BAE Systems, but there are lots of smaller companies which have trouble actually attracting apprentices.
I think it all comes back to engagement again, whether that's engagement with local colleges, local providers, but also understanding that there is apprenticeship service, which covers the whole of the country, and you can post all your apprenticeship vacancies on there. And if you're working in partnership with a provider, they'll support you to recruit, they'll help you find people, they can support with interviewing. So it comes back to that awareness raising and making sure that people understand how to get on an apprenticeship, what the support is there available for you, so you can then get the better calibre of candidates. But there is the opportunities there, but I think it's companies possibly understanding where they are and where to find them.
Okay, so to wrap up, could each of you give your perspective of where you think the skills gap is going to go in the next 5 years, and whether or not we're going to be able to bridge that skills gap? Who wants to go first?
I'll go first. I think skills gaps, when you look at it in the sector that we work in, which is primary, you're actually looking at skills that are across the board. So you're looking at resilience, you're looking at creativity, practical application of maths and science. So you're looking at very broad base that can be built on through the system a little bit. So I think when we're looking at where we sit, it's about the upskilling of staff teachers to be able to be more knowledgeable about the sector, to be able to share that. So for us, it's around the teachers' skill sets to be able to pass that on to children. So I would say that bit.
I totally agree with the skills of the teachers coming through, and if I could recruit lots of people here today if they're keen to come into teaching and training engineers, that would be a real benefit from events like this if we had the opportunity to engage with people, because we've got huge interest for our programs. The numbers are growing. We work really hard in terms of positive role models. They've talked about gender, and over 20% of our apprentices are females, so we're seeing that development over time as well through use of positive role models. But for us it will be finding the trainers that can deliver bigger numbers as they come through, as equally as much as the skills that we've got to fill.
It won't surprise anybody, I agree with both of those things just been said there, but I have to, one of the most difficult things about looking at a looming skills gap is predicting where it's going to go. All the indications are the forecasts are slightly better now than they were a couple of years ago, but I can't stress the slightly is very slightly. And whilst things are a little bit better in forecast, that's because of a massive amount of effort from lots of people. The requirement for those technical skills is growing though. So unless we do more, the gap will just continue to grow and it just won't ever get better. We have to invest in young people. We have to take a leap of faith that you've got to get to people at a young age and convince them to do that. But we also need to seriously look at our education system and how we teach people, how we enable them, how we make sure we offer that advantage universally, and I mean across the whole country, not just in isolated pockets where that happens to be easy. So we've got to make it fair, get to everybody and give everybody the same opportunity. Lots of people out there who would be engineers and technical experts in their various fields don't get the opportunity now, and therefore they never aspire to do that, and we miss out hugely.
We'll have to meet up in a few years' time to see where we're placed. Thank you very much to all our panellists for their time, and thank you for joining us today. Thank you.